Yes, good afternoon, ladies and gentlemen. Um, I've been having a bit of a brainstorming session with some of youngsters that they are trying to intimidate and talk about designs of concrete bridge using Midas. I also tried to convince them that Midas is, for now, is a way to go for most of these young engineers who would wish to really master this field in the industry, and also to move faster as required because of many conflicting tasks. Normally, certain softwares require a bit of time to model and then generate what is required. But I think Midas, with my experience in the industry, seems to be user friendly and faster to pick up and also adopt. So this is what we have. We try to model a 12-meter span reinforced concrete bridge. In this case, this is simply supported. This is simply supported span. And then with a U type of wing wall, and then having a spread footing. This is on assumption that it is bearing on rock, well anchored using dowels or keying into the rock surface. This deck is connected to the abutment using for this model is using elastic links to simulate bearings. The bearing adopted for this case is elastomeric bearing, but normally choices of bearing depends on the type, the durability, the capacity. If the reaction values are not very high, sometimes rubber bearings and elastomeric bearings tend to take precedence, and normally that's what we adopt. So this is a simple bridge. Just I used it to demonstrate to the young engineers I normally discuss with, and I thought it's also wise that it's also good that we share so that one or two can pick and also advise where necessary. The tapering thing, basically, Midas doesn't design for tapering. It uses rectangle or square, so that's why this was supposed to be 800 going to 600, then in between about 700. So this one can be modeled and redesigned straight away without a problem. And normally, as a starting point, an engineer needs to be very careful. You have to understand the entire structure. So before even you go to model, you need to first go and have a sketch, and then when you have a sketch like this, you try to understand what you're going to model. What is it that I'm modeling? So you look at it. Sometimes even you draw. That's why it's important. You must have some basic AutoCAD, because modeling is an art. You have to know the node system, the area system, so that you are able to do that. So you find you have some few sketches understanding center line of bearing, what need to be done, what are the allowances. The hydrology guy will give you his opening. Then for you start. The 11.2 meters will be internal. Then now you from there you should be able to know what need to be done. Then that would be the 11.2 is not the bearing. That is only for hydrology, and the 6 is assumed to be the inclusive of the freeboard. The 2.5 also is assumed to be the square depth determined by the hydrologist. So you have to be, so you just need to know what is there. You do a sectional view. You need to understand, you look at the typical section. For slab bridge, normally bearing can be even at 1 meter to simulate exactly the 1 meter uh, philosophy of slab design or wall design, the linear stuff. So, but for demonstration purposes, we adopted like 4 space at 3 meters. So you have a crash barrier. The 300 was an error, it should be 450. The 17 should be 155, which is the effective walkway. and then you have a 10. This 10 comprise of the two carriageway of 3.5, 3.5, then the 1.5, 1.5 are the soldiers. A brick being a road, this curb to curb must be exactly reflecting the road width, so that when you are driving across, you don't again have some constriction. So that's exactly what you have. Your abutment wall, then come down. These are sketches that normally guide the modeler. Modeling is not just anybody waking up and you jump onto the software. No. You have to first get your paperwork, do all that, because sometimes these models, softwares, handle center line. You see now for this foundation, I'm doing the center line. So you have to be a bit careful in this. You have all the sketches for the national lane. You can either use the H distance as your basis, or you do the center line. So you can see how the calculation has been done. And then also the issue of soil pressure, surcharge, hydrostatic. You first have to make sure you have all that, you do it. So you can have some sketches to help you, because what we input in the computer should be basically something that will reflect exactly what it, even if you were to design manually. So this is exactly what you need to do. Bearing elastic bearings, the bearing details are given. You come down, and this is exactly what you need to do before you start modeling. This is key. You have to do it. Short of that, you will always have errors and you'll not conclude. Thank you so much.